So 1.3, we're talking about inscribed angles, and we're doing geometry, so there's just a lot of vocabulary that gets thrown around, and we need to know what that means. Okay, so an inscribed angle is this angle right here. Angle Q. We looked at central angles last time, now we're looking at inscribed. So see how the angle, this part is called the vertex? It's on the edge of the circle. So our definition here is an angle with its vertex, that's this point, on the circle. And its sides formed by two chords. So right here, this is a chord, and this is a chord. And that makes what we call an inscribed angle. Okay, inscribed polygon. So a polygon is just, it's not a triangle, but it has more than 3 sides. It could have 4 sides, 5 sides, 6 sides. A polygon, whose sides are chords. Right here I have 1 chord, 2 chords, 3 chords, 4 chords. And that creates a quadrilateral inside this circle. So we have a theorem that I'm calling theorem 1, but they're just going to go in order through this unit. So we have 2 and 3 in here too, but theorem number 1 says the opposite angles of a quadrilateral. So a quadrilateral is a 4-sided polygon inscribed in a circle. That means inside a circle, are supplementary. That means they add to 180. So opposite angles, so angle G plus angle E add to 180 degrees. They're opposite. Then angle D plus angle F add to 180. Opposite angles in a quadrilateral. Okay, inscribed triangle. So I hope you notice inscribed. That means inside a circle. So now we have a triangle inside a circle. So any triangle inscribed means inside of a circle with the diameter as a side is a right triangle. So look at my circle right here. Here's the diameter. It's a side of a triangle. So that means that this angle here is a right angle. Angle Z, the measure of angle Z is 90 degrees. So that's whenever we have the diameter as a side. Okay, that's not a theorem, but it's just something that we see all the time. But I have theorem 2 and theorem 3. Theorem number 2, the measure of an inscribed angle is half the measure of the intersected arc. So I have 2 chords here that make an angle of 30 degrees. This one. That means the arc between those points up here is double. 30 to 60. Happens every time. And then notice the central angle is also 60, because these match. That's what we learned last time. But the angle past that is half. Okay, theorem 3. If 2 inscribed angles intersect the same arc, then those angles are congruent. So let's look at this arc. I have an angle right here. So that angle makes that arc, and also this angle makes that arc. So since they make the same arc, they have the same angle. Makes sense, right?